Okay, good morning students once again. I hope you all are well and feeling fit and fresh for another video on matrices. Okay, so if you remember in the very first video we had discussed some of the theory part related to a matrix. Okay, and we had discussed a number of kinds of matrices. Okay, and I had told you that in the next video we will start with some of the operations involving addition, subtraction and so on, okay, involving a couple of matrices. Okay, so let us have a further look into what we have to do today. The first thing that we will start with today is the transpose of a matrix. Okay, the term is transpose. Let me spell it out for you. Transpose, transpose of a matrix. Okay, now although the word itself seems to be a little complex to understand, but the meaning of what a transpose of a matrix will be is quite easy to understand. If you see over here, a new matrix with the rows and columns interchanged. Okay, so if you are given a matrix, let's say for example a particular matrix A has been given, you can have a look at the example over here. For example, if a matrix A is in this particular form, okay, so what do you understand from this particular information? This is a matrix. Now what are the different things that we can know by looking at this particular matrix is, first of all, it has two rows. Okay, you can see that it has one row, second row. Okay, similarly it has three columns. Okay, so two rows and three columns. Okay, so what will be its transpose matrix? Okay, so every matrix, if you want to represent it in terms of its transpose matrix will be an entirely new matrix. Okay, and its symbol will be represented like this. It will be represented with the original letter A, okay, for the original matrix, and at the top right hand corner with a small letter T, we will write with a small t, we will represent the transpose of that matrix. Okay, so this A at the top, small t, this itself is a matrix. Okay, and this will be called the transpose of this matrix. Okay, so the transpose, as the definition suggests, the rows and the columns will be interchanged. Okay, so now what does that mean? Look at the original matrix A. The first row was 2 3 0. Okay, 2 3 0 were the individual elements in the first row. So this first row will become the first column in the transpose matrix. Okay, so the first row has become the first column. As you can see, 2 3 0 are the elements of the first column in the new matrix. Okay, similarly the second row, if you see, 1 2 5 are the elements of the second row in the original matrix. Okay, so 1 2 5 will become 1 2 5, which are the elements of the second column in the transpose matrix. Okay, so the first row becomes the first column, the second row becomes the second column in terms of the individual entries. Okay, so this is all that you have to do as far as the transpose of a matrix is concerned. Now before we move ahead, there is a small observation but an important one over here. If you look at the order of this particular matrix, you will write, if you remember, we will write in terms of the rows and columns. If you see, there are 2 rows by 3 columns. Okay, so the order of the matrix, of the original matrix, was 2 by 3. Now have a look at the order of the transpose of that same matrix. Okay, so this matrix now has 3 rows and 2 columns. Okay, so its order will become 3 by 2. Okay, so the order gets interchanged as well. Okay, so the number of rows become the number of columns, the number of columns become the number of rows, obviously because we are interchanging them according to the definition. Okay, so please remember the transpose of a matrix and how is it obtained. Okay, then the next thing that we will discuss is the addition of the matrices. Now we are starting with the operations on the matrices. Okay, addition of the matrices, any two matrices if you take, you can take 3 matrices also. Okay, but the important condition for you to remember for addition of two matrices to take place, the important condition I have listed over here is order of the matrices should be same. They must be same. The order must be same. You cannot add two matrices having different orders. Okay, so I have listed one example over here in the beginning. Example 1, there is a matrix A, this matrix, and then there is a matrix B, which is this matrix. Okay, it says A plus B is not possible. Why is it not possible? Is because if you see, if we write the orders of these matrices, the first one will have an order 2 by 2, whereas this one will have an order 2 by 3. The orders are not same, so their individual elements cannot be added. Okay, so to understand this this particular rule better, why is this condition present in case of addition of matrices? This example 2 will help you understand it better. Now you see, there is a matrix P minus 1, 8, 7, 0. Okay, so 2 rows, 2 columns. So the order will be 2 by 2. Similarly, there is another matrix Q, 3, 0, minus 1, 5. Again 2 rows and 2 columns. Okay, so the order of these two matrices are same. Okay, so 2 by 2 and 2 by 2. Then if they ask for the addition of these two matrices P plus Q, how is it that you will add them? Now you see, the individual corresponding entries will be added. Okay, so the first thing that you will do over here is P plus Q. So in place of P, you will put the P matrix, okay, then a plus sign, and then in place of Q, you will put the Q value, which is the Q matrix. Okay, so then in the next step, what will you do is you will add the individual corresponding entries or the elements. If you see, the very first element of P has to be added with the very first element of the Q matrix. Okay, so minus 1 is going to be added with 3. So you see over here. Similarly, this entry, which is the second entry in the first row, should be added with the second entry in the first row of the next matrix also. So minus 1 has to be added with 3 and this has to be added with 0. Okay, so 8 plus 0. Similarly, this entry over here will be added with this entry over here. Why? Because these are corresponding entries. Why corresponding? Because you see, this 7 is the first element of the second row. Similarly, this minus 1 is also the first element of the second row in the other matrix. Okay, so this 7 will get added with minus 1. So 7 minus 1, okay, because there is already a minus sign over here, this, and then this 0 gets added with this 5. Okay, so these are the steps that you will have to follow. Eventually, in the end, what you will get is minus 1 plus 3 will give you 2, 8 plus 0, 8, and so on and so forth. So this is the answer that you will get, and as you can see, the addition of these two matrices of the same order has given us a resultant matrix which also has the same order as the original matrices. Okay, so please remember, in case of addition of any 2 or any 3 matrices, you will have to first of all ensure that all those matrices that are getting added, they should have the same order. If they don't have the same order, you will not be able to pick out the corresponding entries to be added. For example, in this example, once again, if we go back to this example 1, you can add this 2 with this 2, you can add this minus 1 with this 0, but then what will you add this 5 with? Okay, so the orders are a mismatch, the elements are mismatched. Okay, so there are no corresponding elements to add. Therefore, please remember the condition, order of the matrices must be same for matrix addition as well as matrix subtraction. Okay, so you see over here, same rule applies for subtracting the matrices also. Okay, now coming down to the multiplication of a matrix by a scalar. Okay, now this scalar word over here, you can just consider this to be a particular singular number. Okay, it can be a fraction, it can be a decimal, it can be a whole number, an integer, whatever. Okay, so we are going to multiply a given matrix by a singular number. Okay, so this is what we are going to discuss, taking an example. Okay, so what is the example that we are taking? This is the example. There is a matrix A. Okay, this is the particular format, and these are the individual elements of this matrix, and the question is find 1/3 of A, or 1/3 into A. Okay, now what this particular thing means is that we are trying to multiply 1/3, which is a scalar number, which is a number, okay, with another matrix. Okay, so the matrix is matrix A. Okay, so what we are going to do over here is, therefore let us write down the solution. We have 1/3 A will be 1/3. Now 1/3 is already a number, okay, multiplied by, now we will write the matrix A over here, 3 0 -3 6 3 0. Okay, so that's the first step. Okay, now please understand the rule of multiplication of any matrix with a number. This particular number will go inside and it will multiply all the individual elements inside that matrix. Okay, so if I am to represent that over here, 3 will be multiplied by 1/3, then 0 will be multiplied by 1/3, then -3 will be multiplied by 1/3, then similarly in the next row 6 will be multiplied by 1/3, 3 will be multiplied with 1/3, and 0 will be multiplied by 1/3. Okay, so effectively what has happened in this step is this number, scalar number, has gone inside. Okay, so 3 gets cancelled. Now you know the basic multiplication process. This will give you a 1, this will give you a 0, this will give you a -1, similarly this will give you a 2, this will give you a 1, and this will give you a 0. Okay, so all these cancellations you can do. 3 gets cancelled, then 3 2s are 6. Okay, this is the way you are going to multiply a matrix with a given number. Now this particular number may be a negative number, it can be a positive number, it can be any particular number as far as the number system is concerned. Okay, okay, so here are a few questions that we will now discuss, just to bring a little more interest into what is going on. Now since you have studied a lot of theory involving a number of things, now we will go ahead and solve a few questions. Okay, now the first question is, I have written down two separate questions over here. We will try to solve them. Question number 1, find small a, b, c, d if, now this is one matrix, this is another matrix, and they are equal to each other. Okay, so if you remember the first lecture, equal matrices, we had discussed equal matrices. There are two matrices will be called equal. They can be equal if their individual elements are equal and their order obviously has to be same. So if you see, these two matrices are of the order 2/2 and 2/2, 2 rows 2 columns. Okay, so they have already given that these two matrices are equal. Okay, so let us start with the answer 1 or the solution 1. You can say that from the information given, now what is the information given? This matrix equal to this matrix. Okay, so if these two matrices are equal, their individual elements which are corresponding will also be equal. So if you select the very first entry of the first matrix, first entry of the first matrix means select the first row, select the first column. Okay, so this is the element which is present in the first row and the first column. Okay, so it obviously has to correspond with this entry of the second matrix. Okay, so this is that entry. Okay, so this corresponds with this. Okay, so we can write a plus 3 is equal to -1. Okay, so this will give you a equal to, this 3 goes to that other side, so you have -1 -3. It will give you the value of a as -4. Okay, similarly if you want to compare the second one, second one means what? second entry in the first row. Okay, so first row, second column. Similarly, first row, second column. So this is that second entry that I am talking about. So this 4 corresponds to this C minus 3. Okay, so similarly you can write 4 is equal to C minus 3. Therefore C becomes, this minus 3 will go to the left hand side, it will give you 4 plus 3, which will be 7. Okay, similar. So what all have we got? We have got the value of A, we have got the value of C. So B and D are what are remaining. Okay, so similarly now you see this minus 2 and this D plus 1, they are corresponding entries. Okay, so you see minus 2 will be equal to D plus 1, D will become minus 2 minus 1, so D becomes minus 3. Okay, so we have got D value also. Similarly, if we equate this with this, B minus 6 will give you 2, therefore B will be 2 plus 6, the value of B will be 8. Okay, so this is how we will get A, B, C, D values. Okay, so once you've got that, you can write down the final answer. Okay, so this was a question on equal matrices. Okay, now coming to question number 2, find the transpose of the following matrices. Find the transpose. Okay, so this is what we have done in the very beginning of this video. Okay, transpose of a matrix is a new matrix which is obtained by interchanging the rows and columns of the original matrix. Okay, so let us have a look at the A part. Okay, first. Okay, so what is the order of this particular matrix? Let us see. If this is the original matrix, suppose this is matrix A. Okay, if this is matrix A, it has one row and it has 3 columns. In fact, it's a row matrix. Okay, if you remember the definition of a row matrix has only one row. So this is a row matrix. Okay, so if you want to make the transpose of it, okay, so the transpose, if you remember, the symbol representation is A with a small t at the right top corner. Okay, so the first row will become the first column. Okay, so 5, 7, 3. Okay, now is there a second row present? No. So that completes our transpose matrix. Okay, so the order of this transpose matrix, if you see 1, 2, 3 rows are there and there is only one column. Try to compare the order of the transpose matrix with the order of the original matrix. Again, it has interchanged. Okay, because we are interchanging the rows and the columns. Similarly, now let's start with the B part. We will suppose this is now matrix B. So the transpose of matrix B will be written like this, and once again you just have to interchange the rows. So the first row is 2, 3, so that becomes the first column. Similarly, 5 minus 4 was the second row, it becomes the second column. Okay, so that is what you have to do in terms of the transpose. Okay. Okay, so here we are with the third question. Okay, third and the fourth also I have written over here, but first we will be discussing the third question. Given matrix A is this, matrix B is this, and C is this, find a matrix X, that is capital X because it denotes a matrix, such that A plus X matrices is equal to 2 times B matrix plus C matrix. Okay, so let us take that original equation that is given, and so I am going to write down solution 3 over here, solution to this third question. Okay, first we have to write the matrix A. Okay, so we will write 2, minus 1, 2, 0, that is our matrix A, plus you have a matrix X. Okay, X is what we don't know, so we will let X be like that. Okay, equal to 2 times the matrix B. Okay, so the matrix B, I am going to just write it down over here. We have this as matrix B, and then plus we have a matrix C. So the matrix C has these values or these numbers or the individual elements. Okay, so this is what was given in that equation. So we have put the individual matrices according to where they should be. Okay, now the next step obviously will be 2, minus 1, 2, 0. This is matrix A, which is the first matrix, plus X is equal to, so the first step, as you can see, this 2 is a scalar, okay, so it will go inside and divide the individual elements. If you remember the multiplication of a scalar with a matrix, okay, so that scalar goes inside and multiplies each individual element. So 2 into minus 3 will give you minus 6, 2 2s are 4, 2 4s are 8, and 2 zeros are 0. Okay, so that becomes this, and then we have plus 1 0 0 2. This was the second matrix that was already present. Okay, so once again we have 2 minus 1 2 0 plus X will be equal to, so now if you have a look, these are the two matrices on the right hand side which are getting added up. Okay, so their orders are same, so the individual elements will be added together, individual corresponding elements. Okay, so this minus 6 will get added with the 1 over here. Okay, so we have minus 6 plus 1. Okay, and then we have 4 and 0 giving you 4, then 8 and 0 giving you 8, and 0 plus 2 giving you 2. Okay, so this is what you will write over here. Okay, so obviously I can write minus 6 plus 1 will make it minus 5. Okay, so this is what we have got on the addition of the two matrices on the right hand side. Okay, so your matrix X, which was to be found out now, will become minus 5 4 8 1 minus. This matrix, if you see, it was getting added on the left hand side, so when it moves to the right hand side, we will subtract that particular matrix. Okay, so 2 minus 1 2 0. Okay, if you can see now, X is the matrix X is the only thing which is remaining on the left hand side. So obviously whatever is the answer to this subtraction will give you the matrix X. Okay, so let us go ahead and try to solve this what we have over here. So you see, once again the corresponding elements will be subtracted. So minus 5 minus 2. Okay, so let me write that down over here. Minus 5 minus 2, that's the first entry. Then the second corresponding entry, if you see, this is 4 over here and this is minus 1 over here. So 4 minus, this is this minus of minus 1. Okay, so that's there. Then we have 8 and 2 as the corresponding entries. So 8 minus 2, and then we have this 1 corresponding with this 0. Okay, so 1 minus 0. Okay, that is what we have here. Okay, so the last step, matrix X becomes equal to, now that's the final step, minus 5 minus 2 will give you minus 7 over here. 4 minus of minus 1, so minus minus becomes plus, 4 plus 1 becomes 5. Okay, 8 minus 2 will give you a 6, and 1 minus 0 obviously will give you a 1. Okay, so that is your matrix X, which will be the final answer according to the question asked. Okay, okay, so now moving on to question number 4. Find matrices A and B such that A plus B, their addition is this matrix and their subtraction is that other matrix. Okay, so these are the informations given in the question and we have to find individual matrices A and B. Okay, so now we'll solve this particular question. As you can see, I have listed down what was given to us one below the other. The reason being that just like you do in the solution of linear equations, okay, there are two variables which are generally not known. So there are two equations that are given to us and we have to eliminate one of them to find the other. Okay, so writing them one below the other, what happens is when you add them, okay, when you add the first and the second one, what happens is a plus a, you get 2a on the left hand side, whereas plus b and minus b gets cancelled. Okay, so 2a is equal to, now obviously when you have added things on the left hand side, you will add on the right side also. So on the right side, obviously there are two matrices that have to be added. So you will first write them down like this: plus 11, 2, minus 1 and 7. Okay, so this is how you have written. Now 2a is equal to, so let us go ahead and add. So we will add 5 plus 11, then 4 plus 2, okay, then 7 minus 1. Because this number is a negative number, then we have 3 plus 7. Okay, so this, if you see, it is going to give you 5 plus 11 will give you 16, 4 plus 2 will give you 6, 7 minus 1 is also 6, and 7 plus 3 will give you a 10. Okay, so that is what you have got as 2a. Okay, so 2 times a matrix is this. Therefore, your matrix A, now you see this 2 is a scalar number which is multiplying matrix A on the left side. So when it goes to the other side, when it goes to the right hand side, it will divide on the other side. Okay, so it goes to become 1 by 2 on the right hand side, and then we have the matrix 16, 6, 6 and 10. Okay, which is going to give you, obviously when 1 by 2 is getting multiplied with this matrix, when it goes inside, this is a scalar quantity, so when it goes inside, it will do the multiplication with all the individual elements. So the first element, as you can see, it will become 8, because 2 8s are 16, then you have 2 3s are 6, then you have 2 3s are 6, and you have 2 5s are 10. Okay, so your matrix A finally comes out to be 8, 3, 3, 5. Okay, this is, please remember, this is only one part of what they had asked. They had asked find the matrices A and B. Okay, so matrix A you have now got. Okay, matrix A you have got. What will you do now? So supposing that this was your equation number 1 and this was your equation number 2, or condition 1 and condition 2, what you can do now is put the value of A either in this one or in this one. You will get the value of B simply by using the same method of taking things on the right side and left side. Okay, so the next step, I am not going to solve for the calculation of B. What I am going to write is put A value or the A matrix in 1 to get matrix B. Okay, so this is what you have to do. You can complete this in your notebooks, the calculation for the B part, because now I am going to take you up to the last question of this particular class, which is question number 5. Okay. Okay, so now here is question number 5 that I have written. First, please read it carefully. If 3 times this matrix plus 2 times this matrix is equal to another matrix, third matrix, find the values of x, y and z. All these are in small letters, that means these are individual elements, not matrices. Okay, so x, y, z, if you see carefully, there is x over here, there is y over here, and there is z over here. Okay, so these are unknown quantities. This is the relationship given. Okay, so we will start with solution of question number 5. Let's see. Now 3 is getting multiplied, so it goes inside and multiplies. 3 2s are 6. Then you have 3 into x giving you 3x. 3 into 1 will give you 3, and 3 into 0 will give you 0. Okay. Plus, similarly, this 2 goes inside, so it multiplies. 2 4s are 8, 2 3s are 6. 2 into y will give you 2y, and 2 into 2 will give you 4. Okay, equal to, so on the right side there is nothing to be done just now. We will simply copy down the matrix that was given. Okay, now on the left hand side, if you see, these are the 2 matrices which are getting added up. Okay, so the individual elements once again will be added up. Okay, so 6 plus 8 will give you 14. Okay, 6 plus 8 will give you a 14. Similarly, 3x plus 6 cannot be added as such because x is a variable. Okay, so 3x plus 6 we will write as such. Similarly, 3 and 2y, they have to be added, so we will write 3 plus 2y. Okay, and 0 plus 4 obviously is going to give you a 4. Okay, so on the left hand side, after simplification in 2 steps, we have got this as the final matrix, and on the right hand side, if you see, there is still nothing to be done as of now. Okay, so these are the 2 matrices that we have finally obtained, and if you see, their orders are same, 2 by 2 and 2 by 2, and there is an equal sign in between. That means these are equal matrices. If they are equal matrices, then their individual elements will also be, individual corresponding elements will also be equal. Okay, so therefore this number 14, which is the first element in the first matrix, will be equal to the first element in the second matrix also. Okay, so this Z and 14, they correspond to each other. Therefore you can say, comparing, because these matrices are equal, comparing, you see Z becomes 14. That's the first thing that we have found out. Similarly, now you see this second entry over here and this entry over here, they have to be equated. So 3x plus 6 is equal to minus 3. Therefore 3x will become minus 3 minus 6. Okay, so 3x becomes minus 9. Therefore x becomes minus 3. Okay, so Z value we had got, we have now got the X value. Similarly, now comparing this entry with this corresponding entry, what we can do is 3 plus 2y is equal to 15. So 2y becomes equal to, 3 goes to the other side, gets subtracted. So you will have 15 minus 3 coming out to be 12. So y becomes 6. Okay, so X, Y and Z values we have obtained based on what was given to us. Okay, so these were some of the questions based on the addition of the 2 matrices, maybe the subtraction also, the multiplication of a scalar with a matrix, and some questions on the equality of the matrices. Okay, so in the next class we will be moving ahead, but please practice some of the questions from the book also. Obviously the questions that I had taken over here, these 5 questions, they were also taken from the beginning first exercise of matrices. Okay, the unsolved questions. So please do some practice on your own also. Thank you.